The halting problem. It initially extends from the decision problem, which is something mathematicians in the 20th century were trying to solve. It essentially states, given a set of premises or initial assumptions around a concept, is it possible to draw a definitive conclusion as an output? In 1936, Alan Turing determined that this was impossible using first-order logic. The 2014 movie, The Imitation Game, is loosely based on his work there. And the way that Alan Turing solved this is essentially by using contradiction. So in computing, the halting problem as it relates effectively says, given a description of an arbitrary program and a set of inputs, is it possible to ever know if that program will halt? And what halt means in that sentence is, will it ever return a result or just keep running forever and just kind of churning through, never really giving you an answer? So let's say, hypothetically, this is most often sort of described using what's called a Turing machine, which is sort of an abstract machine kind of descriptor of a mathematical model of computing. So let's say we have this magical machine, and it can take an input of a description of a program and a set of inputs. And let's say from that, it will definitively tell you if this program ever halts or does not halt. So it'll either say yes or no. So let's say we take that and we take the output from that machine and we feed it into another machine, which, given a yes, will loop forever. It'll just run and never return. It will never halt. And given a no, it will halt immediately. We take these two machines sort of together as one new machine, and we feed that machine as a descriptor input to our original magical machine. And from that machine, effectively, if it halts, it will never halt. And if it doesn't halt, then it will halt, effectively, which is a paradox. It's a contradiction. If it halts, it doesn't halt. If it doesn't halt, it halts. The wall behind me is taken from the Boyer-Moore theorem, which proves the unsolvability of the halting problem generated in code and described here using Lisp.